In the previous video, we saw how we can take a .c file, compile it into an object code file, first.o, and then link it with all the functions and other things we need from the standard GNU C library and create an executable file which we can then run. So you can't really run first.c or first.o, but you can run this executable file first. So you can try that out. Let's take a quick look at some of the details of this simple first program. So the very first line was a #include and then the name of a file. So this is called a header file. It ends with a .h for header. And what it has is the definition for this printf function. It doesn't have all the details of printf, but it has a basic definition. It says, here's this, and it sort of just declares that function. And it says, okay, there is a thing called printf somewhere, and you have to, later on, at some point, you have to get the code for it from the GNU C libraries, the GNU or glibc, or glibc. Okay, after that comes what we're used to in Java. As in C++ and Java, every C program has to have one main function. You cannot have two main functions. That just won't work, because the main function is where the program starts execution. So if you have two main functions, the runtime system will get confused and say, well, which main function should you use to start? And so you only have one main. And we'll have, so main is just a function. You have a return type, you have a list of arguments that can be null, or that is, it can be empty, you can have no arguments, or you can have one or more. And then the rest of this function is enclosed in open curly braces and closed curly braces. So this is one compound statement, as it is in the same case in Java and C++. You have a function with one compound statement. Within this compound statement, within this the body of the main function, you can have any number of statements, just like in Java, and they're executed sequentially, unless you have some loops or some complicated control flow system. Okay. So return, in this case, has an argument. Return is sometimes written with parentheses, but you don't need the parentheses, so you don't need to say return open paren 0 close paren. Just don't need that. You can just say return 0. Whatever you return has to agree with the return type declared in the function definition. Okay, so in this case 0 means everything worked, and so that's also interpreted as true in some situations. So if you return 0, it's true. If you return positive or negative, it's sometimes interpreted as returning false. So unfortunately, that's the way it works in certain situations. If you're used to Java or C++, you know that in a string you can have the \n, and that is interpreted as a new line character. So if you try omitting this and compile and run the program, you'll see that you'll print out hello world and then the bash prompt. So since that doesn't look that great, you put in a new line character, and then you get your prompt on a new line, as was shown here. So that's \n gives you a new line, and this prompt gets printed on a new line. If you didn't have it, this prompt would show up right here along with the output of your program. So doesn't look as nice. Okay, so couple of differences. There is no print line function. There's only printf and fprintf and things like that. So it's a little different from Java. In Java, you can have print lines and printf. Okay, so a word about header files. Header files are files that exist in the system, it's usually, well, a lot of them are already on the system, but once we get to writing more complicated C programs, we will set up our own header files. So right now we won't. Right now we will just use files that exist. So for example, stdio.h, that's standard IO, that defines defines functions like printf. So there's a definition for printf in standard.io.h. The pound include is a C compiler preprocessor directive. That is a directive that belongs to this part of the C compiler that does some pre-processing with your C code. And what it does is it takes the contents of this file standard.io.h and then generates a temporary file with the contents of stdio.h at the top, followed by the rest of first.c. And you create a temporary file, and that's what's compiled by this actual C compiler. So there's a C compiler preprocessor that does some processing on your source code, your .c files, creates a temporary file, and then that's what's compiled into object code. Or if you can, and we'll see how we can. Most of the time, we will skip compiling to object code. We'll go straight to the executable, sort of. Okay. So this is shown schematically. If you have a pound include, and you can have any number of pound includes, just like you can have many imports in a Java statement, or in C++, you also have the idea of pound includes. You can have any number of these, and these are all included in order, in the order specified. This will create a temporary file that consists of standard.io.h in this case, and the code from your first.c. It's joined together in one file. And then the C compiler takes that file and creates an object code file. A header file is allowed to include other header files. So if you look into standard.io.h, let's see if we can find it. That standard.io.h file may include other files as well. Chances are it does. So if you had a pound include, there's two ways you can use pound include: with the diamond bracket notation, which says look for this file xyz.h in the standard places like /user/include and so on. These are actually specified by default. GCC looks in places like this /user/include. You can also set up your own quote-unquote standard place, and then you have to say use this folder, and in that folder look for .h files. So you can do that yourself, and we probably will do that as we get further into C programming. The other way to use pound include is to use double quotes, and there whatever you have in here in double quotes is the name of a file that's supposed to be in the current directory. So you should have, if you say pound include double quotes some xyz.h, that means you're saying that there is an xyz.h in the current directory. As far as I know, you can do things like include the same file twice. I don't think it'll give you well, actually you might have redundant definitions, and that might give you problems. So best to just include each file just once. So let's see if /user/include/stdio.h exists. There it is. Okay, good guess. Let's take a quick look and see how big it is. It is pretty large, about 18K. So we don't want to look through all of that. We'll just look at the top. We'll do that with head. And there's all the copyright notices from, in this case, Apple. And let's do less or more, either one is fine. So if you're doing this on Linux machine, you will see the copyright notice from the GNU Foundation. So this is slightly different, but it'll be roughly the same idea. So for example, note that there's all these if-and defs. We'll get into that later. And then after that you'll see more pound includes. That is, this stdio.h includes other files, and if you were to look in some of these .h files, they probably include other files too. So that preprocessor has to take all of this stuff, this big huge, and the best way to describe it is as a tree of files. It gets all of that, creates a temporary file with your code in it. And you'll see a bunch of other things that we will talk about later. Okay, that's good. Okay, now let's take a look at these pound defines. We saw some of this in the stdio.h, and you can take a look. You'll see these pound define directives in many of the .h files. You can also put it right into your C program. What this is an easy way to define constants. You can take a look at any .h file, .c file, and you'll see pound defines. So, for example, you might see something like this: pound define file count 10 means that file count is defined to be a constant called 10. Or you can use it to say file name is something in double quotes. Or you can even say, you can pound define a type. So you can say that wherever you see integer, what you really mean is int. So these are C preprocessed statements, and one thing to note is they do not have semicolons. So do not put a semicolon. That's a common mistake. If you put a semicolon here, what happens is the reason that doesn't work is mainly because pound define is kind of dumb. That all it does is scan your code, and for every occurrence of file count, substitute whatever's next. So if you put a semicolon here, you will end up with a 10 semicolon followed by another semicolon. That's going to mess up the compiler completely. So you'll get error messages. So do not use semicolons here. Although it's tempting to think that this will work just like a C statement, it doesn't work quite the same. And you can have any amount of text here. You can also have loops and all kinds of things. We won't do much of that, but you can do that. It's a very simple directive. All it does is takes the first thing. It says, okay, from now on, wherever I see this thing, file count in this case, I will substitute whatever's on the rest of this line. So if you have 10, it'll go down and substitute 10 for every occurrence of file count. If you have something like this, you have a string in double quotes, it actually includes the double quotes and everything. So wherever you see file name, you'll get double quotes text.in. So it's a very sort of dumb directive. It's not like the final declaration in Java or the const declaration in C++. So the string at the end of the pound define is substituted for all occurrences of this name. It's usually found in header files and at the top of C files.